just did the Nearpod with the displacement graphs, right? And I want to talk about another type of graph that we will have sometimes. And that's the velocity graph. So here's what I want to think about. I want to consider a car moving forward and slowing down. So if we were to do a motion map like it talked about on the Nearpod, it would look something like this, right? We would start out going fast, and then we would slow down over time, so they'd get closer and closer together. I want to make two graphs. I want to make a displacement graph for this motion. And then I want to make a velocity graph. So velocity versus time. So this is what you were doing in the Nearpod, right? What would it look like? If I'm going forward and slowing down, how would that look? It's up and then flat, right? So I got to go fast to slow. So this is what the displacement graph would look like. And again, the reason that this shows me speed is because I start steep, which means I'm starting fast, and I end flat, which means I'm going slow. And why does it make sense that the slope of this gives me velocity? Remember, Aiden?
It's rise over run and then meters per second.
Yeah.
Velocity.
Right. If you pick 2 points and do rise over run, the rise is going to be measured in meters because it's a displacement. The run is going to be measured in seconds. So in this case, the slope is going to be velocity. Now, let's think about if we actually plotted the velocity graph, though. The velocity graph isn't going to look the same. Because the way what's going to happen, right, is it's going to say I'm going to be going fast, which is going to mean I'm up here, and then I'm going to be slowing down over time. So over time, I'm going to be losing speed, but it's actually going to be a straight line in this case. And again, the way that this shows me that I'm slowing down is I start with a high velocity up here, and I end with a low velocity down there. Can you guess what the slope of this is going to give us? Any ideas? Well, let's think about this, right? If I pick 2 points and do rise over run, although in this case it won't really be a rise over run, it'll be a fall over a run. But what is my fall going to be measured in? What did you say, Aiden?
I was going to say negative.
Well, it is negative, but what units is it going to be?
Meters per second.
Meters per second, and my run is still in seconds. So if I do rise over run, I'm going to do meters per second, which is what? Acceleration. So the slope of a velocity graph is going to give me acceleration. So I draw out this thing that I call the graph of motion roadmap. And this is saying, like, if I start with a displacement graph, which I abbreviate D, then I take the slope, I get velocity. And then if I take the slope again, I get acceleration. Questions about this? All right, so now what I want to do with this is I want to take a look at then how can you, if I give you one of these graphs, how can I read it, right? So what I'm going to do in the bottom of your notes here is we're just going to make a little T-chart that's got 3 columns. And leave this first column blank. The second column was going to be a displacement graph. And the second column is going to be a velocity graph. And there are 3 questions that I want to be able to ask when I look at a graph. The first question is, which way is the object going? Now, in a displacement graph, so this was the first question on your Nearpod, right? In the displacement graph, how did we know which way it was going? If it was going forward, what did it look like? It went up, right? So if it's got an upward slope in a displacement graph, that's going to mean that I'm going forward. And if I have a downward slope, that's going to mean I'm going backward. That's in a displacement graph. Now, a velocity graph can't do that, right? Because which way, this thing's going down, but is that thing going backwards? No. Velocity graphs have to follow its own rule. How do I know that I'm still going forward here? What would it look like if I wasn't going forward, do you think? Yeah?
If you weren't going forward, it'd be negative.
It'd be negative. So this is what we're going to say, right? If the graph is negative, and the way I'm going to say that is if it's above, or, well, if it's positive, or if it's above the time axis, then we're going to say it's going forward. And if it's below, so if it's negative or it's below the time axis, that's going to mean it's going backward. The second question I want to be able to answer when I look at the graph is how fast am I going? So we've already talked about what does a fast graph look like for displacement? Fast versus slow, what's the difference? Yeah.
How steep is slow?
Steep, right? So fast is going to mean, or steep is going to mean fast in a displacement graph, and flat is going to mean slow. Now, in a velocity graph, what we're going to say is that up here, when I had a high velocity, right, I was very far away from the t-axis. So we're going to say that far away from time axis, far away from t-axis is going to mean fast, and near the t-axis is going to mean slow. I'll show you what I mean by that here in a second. The last question that I want to ask is, what does slope mean? And we've already answered this, right? So in a displacement graph, slope means velocity. In a velocity graph, slope means acceleration.